Hello, third graders. Welcome to math. You're in chapter 10 in your math book, and today we're going to start on page 599. So if you have your book in front of you, you can open up to page 599, and you can see that we're going to be talking about estimating. We're going to estimate liquid volume, we're going to estimate mass. Now, why do we estimate anything? What's the point? Will we ever need to know this? Well, the truth of the matter is yeah, you estimate all the time. You can do it when you're shopping. You can try and figure out how to split things up amongst friends. You think about estimating how much of something will go here or there, or what the relationship is. And estimating also gives us kind of a clue where the exact answer is. So if you're good at estimating something, when you do calculate to get the correct answer, you'll know just how close you were by looking at your estimate. If it's way different than your estimate, then the odds are pretty good that you did something wrong in your calculation. The first thing we're going to look at is estimating liquid volume. Well, what is volume? Volume is what it takes to fill the inside of something. So, for example, what I have on the board here is a water bottle. And, of course, we put water in there. That's liquid, right? Everybody knows that. And we're gonna use this as an example of what 1 liter of liquid would be necessary to fill that container. Now, the whole point of this exercise is for you to look at things and then kind of figure in your mind an estimate of what their volume is, how much it would take to fill it up. So it's really a pretty simple exercise. Let's just do this. Now, if that's 1 liter, and that represents the size of a container that holds 1 liter, if I was to say this cup, does this cup hold more or less than the 1 liter bottle of water? Well, you can look at that and you can estimate just based on its size. The cup is much smaller. Matter of fact, it looks like it's about 4 times smaller. So it may, in an estimate, hold 1/4 of a liter. Now, by the way, liters are a liquid measurement used in the metric system. Another example. Here we have a bathtub. Now, in your estimation, does a bathtub hold more water or less water than that 1 liter bottle of water? Now, I hope you don't have to think about this one too hard, because obviously a bathtub holds a lot of water, way more. And it's even probably pretty hard to estimate exactly how many liters of water would fill that bathtub. But I would guess, just because I'm guessing, well, maybe 120 liters of water to fill that bathtub. But what about What about your fish tank? Now your fish tank can be small or it can be really big and have some really big fish in it. But if you look at a small little fish tank that you might have in your room where you keep your goldfish, you look at the tank and you look at the liter of water and you think, you know, they're about the same size. So I'm going to guess that this little fish tank will hold about a liter of water. But this great big fish tank here, that's going to hold a lot more. That could hold 20 liters of water. So if I had to do a comparison, and if I was asked, is the cup more than or less than a liter? It would be less than a liter. Is the bathtub more or less than a liter? It's definitely more. Our fish tank, well, it's about the same. And our big fish tank, definitely bigger than a liter of water. So, when you look at what it takes to fill one of these objects up, filling it up is its volume, how much it can hold. Then you can make these comparisons and you can actually estimate what you might need to know in case you want to fill up a bathtub and want to guess at how much water it's going to take to fill that aquarium. So that was unit lesson number 10.7. And actually what I'd like to do, while I'm thinking about it here, on page 603, that's your homework, 603 and 604. And what it does on this page is ask you to make some comparisons. And without drawing all of these objects on the board, it's going to do just what we just did. You've got a milk bottle, you've got a little milk container, you've got a water bottle, a teaspoon, a bathtub, and an eyedropper. And it's asking you, in comparison to a 1 liter object, how do they compare? Well, a gallon of milk is clearly more than 1 liter, so it's more like 4 liters. The small container of milk might only be a half a liter, so it's less. The water bottle would be equivalent. A teaspoon would be much less. A bathtub would be much more, and an eyedropper would be much less. They give you a drawing where you have 4 water glasses. And each one of those water glasses has a certain amount of water in it. And it asks you to do a comparison. Now, that one's obviously full, so that's 1 liter, so that's equivalent. This one here is half full, so that's about a half a liter. This one here is barely full at all, so that's probably about 1/8 of a liter. On the other hand, this one here is about 1/4 of a liter. So you're able to estimate and draw conclusions about the volumes in relationship to a 1 liter container. Now the next lesson, 10.8, it talks about measuring mass. What is mass? Well, mass is kind of the weight of something. As an example, you have a paper clip, and then you have a box with a lot of paper clips in it. Which one do you think has the greater mass? One single little paper clip or a whole box full of paper clips? Well, obviously, the box full of paper clips is going to have more mass. Now, in measuring mass, we use liters in the metric system to measure liquids. Mass is different. We measure that in grams, and we measure that in kilograms. Now, if we use 1 gram as our reference point, referencing that clip weighs about 1 gram. Looking at our box full of paper clips, which is much greater, how would we state that? You got 1 gram for 1 paper clip, so what is this? A whole lot of grams? Well, a whole lot of grams is not a measurement in metric. But if you take 1 gram and you multiply it times 1,000, you get a kilogram. A kilogram would be more appropriate to measure that box. That also tells us that if this box is 1 kilogram, that it must have 1,000 clips in it. Do you understand that? Because the difference between a gram and a kilogram is a multiple of 1,000. So if you have 1 paper clip that weighs a gram, 1,000 paper clips will weigh a kilogram. The nice thing about metric is everything's in multiples of 10. Why we didn't ever adopt that system in our country, I don't know. It really is a lot easier. Don't let the fact that it's metric confuse you. It's just base 10. Everything goes by tens, hundreds, thousands. So it's actually pretty easy. Now, there was a problem in this section. Well, actually here, I'll tell you what. Let's do this first. Because on page 607, what they're doing is they're giving you some objects to look at and to determine. Do you measure it, for example, the paper clip? There is a paper clip here, 1 gram. Or something bigger that weighs a lot more than this paper clip. So if you were to try and estimate, you would have to say that the roll of paper towels weighs more than the paper clip, obviously. And in relationship, you'd probably want to measure that roll of paper towels by kilograms. So would you measure a strawberry on a gram scale or on a kilogram scale? A strawberry. grams. A strawberry weighs 2 grams. A whole bushel full of strawberries, though, might weigh 2 kilograms. How would you weigh a dog? Would you weigh a dog like you would weigh a paperclip? No. The dog would be measured in kilograms, just like we would. If I weigh 130 pounds, I can translate that into metric kilograms. A school desk. Would you use grams or kilograms to measure the weight of a school desk? Remember, mass has to do with the density of something, the weight. It would be kilograms. But my glasses, for example, they're pretty light. So they probably weigh 3 or 4 grams. How would you weigh a watermelon? Oh, probably kilograms. It may weigh 1 or 2 kilograms, depending on how big it is. Now, when measuring liquids, you use a measuring cup. And measuring cups are marked, and it lets you know. In this particular measuring cup here, it has metric on one side, standard measurement on the other side, so it measures it in ounces, or it measures it in milliliters, which, by the way, is a smaller unit of the liter. For mass, we use a scale. Why do we use a scale? We use a scale because that's how we determine the mass of an object. Now, when estimating, for example, if we use this scale here, and on one side of this scale, I put a bowling ball, and on the other side of this scale, I put a feather. What do you think is going to happen to that scale? You're right, it's going to take a dive right in that direction. Why? Because this bowling ball has a much greater mass than that feather. But let me ask you this question. Does a pound of steel weigh more than a pound of feathers? Think about that for a second. Does a pound of steel weigh more than a pound of feathers? I hope you got that one figured out. They're the same. Just like if I said a kilogram of steel and a kilogram of feathers. They're equal. They both weigh a kilogram, so yeah. Now, in space, the space they take up, that'll be vastly different. The steel is much more dense. It has much more compressed mass than the feathers, which you'd have a great big pile of feathers to come up with a kilogram. But you can make comparisons and then determine that you would measure that feather using a gram measurement, and you'd measure the bowling ball using a kilogram measurement. Let's look at the homework for this lesson. And let's see if we can't come up with a problem here. On page 608, problem number 11. What you have is 5 different pictures. You have a baseball, You have a ping pong ball. You have a golf ball. You have a tennis ball. And you have a bowling ball. Now, what problem 11 is asking you to do is to put those sport balls in the right order from the greatest mass to the least mass. Now, bear in mind, size can trick you. So as you look at this example, we know a baseball, we know pretty much what a baseball feels like. We know a golf ball, for being so small, is actually a pretty heavy little thing. We know how light a ping pong ball is. They're almost weightless, they're so light. A tennis ball is not all that heavy. It's mostly full of air. And a bowling ball is very solid, very dense, very heavy. So if I had to put these in order from the least mass to the greatest mass, I would have to say that the thing with the least amount of mass would be the ping pong ball. That would be number one. Now, it'd be a toss-up between the golf ball and the tennis ball. But I'm going to go with the golf ball because the golf ball has a greater mass to it internally, whereas the tennis ball's full of air on the inside. So let's go with the tennis ball for number 3. Then the next heaviest thing that I would imagine would be the bowling ball or the baseball, and obviously the most massive thing would be the bowling ball. So that's problem 11 on page 608. Take a look at that and look at your homework. In your homework, they're going to ask you to look at some different things and ask you whether or not it would be measured using a gram or a much bigger kilogram. It gives you a CD as an example, a person, a bag of sugar. It'll also ask you to compare masses, like we did with the bowling ball on one side and the feather on the other. Which one is going to have the greater mass? Obviously the bowling ball. So take a look at your homework on 609 and 610. And if you have any questions, I'm sure Miss Rima would be happy to help you. Meanwhile, I hope what we talked about today, estimating liquid volumes in liters, estimating mass in grams and kilograms. That's the end of my lesson for now. We'll get back to you. We're going to look at solving problems about liquid volume and mass. Yes, you never know when you're going to encounter a situation where you have to actually calculate and solve problems with liquid and solids. We'll do that next. Meanwhile, you guys stay safe, stay out of trouble, and we'll see you in next class.